Good morning all. Package from Lumintop, lumintop.com. They got in touch and they said, would you like to see our new LM34C lithium cell? And I said, yeah, that would be great. They've also sent an ED20T. So I should disclose that this was sent free of charge. Right. The ED20T is a flashlight. So that will go on my reviews channel. Have you seen my reviews channel? If you haven't seen my reviews channel, head on over there and take a look. It's really good. But this is the LM34C. It's a 3400 milliamp hour lithium cell, but with a bit of a twist, because to charge it, you plug a micro USB into that little slot in the top there. Let's get it open and have a bit of a play with it. Right, so this Lumintop cell is described as a rechargeable 18650 lithium ion battery with protection circuit. Then there's a picture of a micro USB lead to make it very obvious that that's what you do. You plug it into that hole. It's 3400 milliamp hours, 3.7 volts, 12.6 watt hours, and it contains a Panasonic NCR 18650B. That's about all it says. On the bottom, a nice branded base plate there. On the top, we've got a button top, but there's also these two holes, and those are actually LEDs. Okay, let's plug in a suitable powered up micro USB. So that goes in there. And it's not very bright, but you can just about see there a red LED has illuminated. And I presume that when this is charged, the other LED will come on. Now with some electronics in the top here, and yes, I am going to take this apart, that's why it's on this channel, you'd think, wouldn't you, that it might add a bit to the length. So let's check the length. I'll line that up exactly there. And yes, I mean, it's actually slightly longer than 7 centimeters. I reckon that's 7.1, so that's 71 millimeters. Nominal size is 65 millimeters. Let's see how it compares with other cells. Here's a no brand 18650 flat top, and you can see there's a fair bit of difference there. Here's a no brand 18650 protected cell. You can tell it's protected by that strip running up the side. Let's line those up, and it is ever so slightly longer than that one too, by about 1 millimeter. So it's a long cell. You'd have to check whether or not that's going to fit your intended device. So on Lumintop's website, we have under features a little bit about the two colors LED indicating charge condition. Red is charging, green is full. It uses a Panasonic NCR 18650B cell, top quality. Now it says anode protection circuit protects against overvoltage, over discharge and short circuit. That'll be useful when I take it apart. It also says here max output current reaching to 4 amps. Now I'm sure the 18650 cell itself can deliver more than 4 amps, so is this something to do with the charge circuit or the protection circuit? More likely that limits it to a 4 amps discharge current. And in the specifications here we have the size, which is actually 70.7 millimeters, so a fair bit bigger than the nominal 65 millimeters. So I just thought I'd check the charging current. So it's charging from a power bank. That power bank is delivering 5 volts, and the charge current is 0.75 amps, 750 milliamps. That's still on red. Now these cells are normally supplied half charged. They should be stored half charged, so that's going to take a little bit of while, I think, before that current starts dropping down. Can I wait for that before I cut this thing up? Nah, maybe. And I can see the logic of this. I mean, USB and micro USB charge leads are, well, ubiquitous. They're everywhere. So if you've bought a torch So say for example this one, this is Lumintop's copper print, which is tarnishing quite nicely actually, and that's the point of this torch, it's meant to tarnish. And you've got a cell which is not got a hole in it for recharging, then you've got to worry about how to recharge this thing, and then you've got the issue of what current do you recharge it at. And if you're not electronics minded, you know, maybe it's easier just to have a cell that has a hole in it, plug in a USB, and it charges safely. Okay, it might charge a little bit slowly, but without all the worry. Right, so this is still charging at 750 milliamps. The top of the cell is moderately warm. I mean, certainly not alarmingly warm. I wonder whether this is charging with a linear regulator. If it's switch mode, there'd have to be an inductor in there, and there isn't a lot of space. In fact, I'm even wondering whether this uses a TP4056, and they've just set it to charge at a little bit less than 1 amp, which is the maximum for the TP4056. Well, we'll find out when we take it apart. Right, I've given it about half an hour, and the current hasn't yet started to fall, so it's still in the constant current phase. I can't find anything on Lumintop's website about how long this will take to charge, but we can work it out. If this was charging at 1 amp, it would take 3.4 hours to charge. Now, of course, it'd actually take a bit longer than that, because the last part of the charge is at an ever decreasing current. That's the constant voltage part of the charge. So it could take, at 750 milliamps, 4 or 5 hours to charge this cell. That's just moderately warm. But I think it's now time to do the teardown. So where do I start? Well, let's start here on the top. I'll just take off this plastic coating. So let's cut that and start peeling that round with some pliers. Right. What are we seeing? We're seeing a cell with a sort of metal bit on the top. Now, I can't be 100% sure that the polarity there is the same as the polarity there. It probably is, because they appear to be joined, but I'm not going to touch anything onto anything, because I don't want a big fire in my house. Well, I thought I'd just check whether this metal top bit is a different polarity to the metal bottom bit, and it doesn't appear to be, although that went down in voltage very slowly. Wasn't a sort of instant zero. Let's get some voltage on there. Does this go instant zero? Oh no, it doesn't. So they probably are connected together. Let's just do that as a continuity check. And that's beeping. This thing's got an incredibly quiet beep. It's ridiculous. Well, I can peel this white disc off the top to see what's in there. And there are a couple of, well, that's a PCB. There are a couple of connection points there. Oh, they're probably the mounting points for the USB socket. Brass top dome thing there. And the lights. So how am I going to get that apart? There does seem to be quite a gap in there, which is why I thought the potential at the top might be different to here. So I suppose I'm going to have to jam something in there and just start levering. Well, this is really quite well constructed. So much so that I think I'm going to have to resort to quite brutal means to remove this top section. But it does look like it's sliding off with a bit of waggling. Oh, yes it has. Oops, got to be careful now because I don't want anything to short. Okay, let's have a look in there. Right, that presumably is the positive of the cell. There's a tab welded onto there which goes up inside the top. There's another tab welded on, let's see if I can get to see it, yeah, just there, welded on the outside of this outer section. Now, I assume that's all negative. This was negative because it was pushed down over there. So that tab runs up in there. Can't quite see what's going on. Yes, it goes actually up through a slot, but that must be all negative because this was connected to that when it was pushed over the top. That tab is positive, and therefore mustn't touch any of this outer metalwork. But I will keep working on that. So what I really want to do is shove my pliers in there and rip that tab off the positive of the cell, but I can't, because I can't put my pliers in there, because I'm just going to immediately short that positive to either this negative at the top or this negative. So really what I've got to focus on is the other tab wire, which is in there. It's not as easy to get to, but it should be, well, it's welded on the outside of this ring, so all this is negative, so I should be able to just get my pliers in there and rip that tab off and then turn this up, but all the time being careful not to let the positive tab touch any of the negative metalwork. It's more tricky than I thought it was going to be. Right, I've managed to cut the negative tab, so we'll have a look just up inside there. Now, of course, it doesn't matter now if I short the positive tab to the metalwork on this top bit. Still don't want to short the positive tab wire to the metalwork on the bottom bit, of course, but I should now be able to just pull that off and force that tab wire away. But I must admit, it is quite scary doing this. It must be even scarier for the people that make these, because they must have to spot weld that tab on, presumably after it's in this cap, and then very gently or very carefully lower the cap down over the cell and press it into place. It's an interesting one. Right, I just pulled on that, and that spot weld broke, and now the cell is released. So I'm guessing this is a standard Panasonic NCR 18650B cell. I'm not sure what this raised top bit is. Obviously, if I touch that with my pencil, I can't remember how many ohms pencils are. Is it high resistance or low? I can't remember. Anyway, nothing untoward happens there. So the cell is at least now out of the equation, and we can take a look at the little charge circuit. Right, I suppose really I should have had a bucket of sand or something, although I'm not even sure that would have been much good. I'm trying to get that black disc out now. That's the positive. That's what that went to the positive cell, that one. The little short one went to the negative. I can't get that out. I know there's some electronics under it, but oh, there it comes. Right, so that's just a cover. Oh, look at that! Lots of chippies! Now, I think there's a bit of double-sided tape or something. Oh, no, maybe not. I thought there was something holding this PCB into this sort of cap bit. It's quite sharp, that edge, so I didn't really want to mess around with that too much. Okay, so now I can take a look at the circuitry on this incredibly tiny board. Right, there are two devices near the socket which appear to say 57 lowercase b3. I think that's what they say, 57b3. So are they the charging devices? Who knows? Now here there are three chips with actually a brand name on them. They're upside down. I'll turn them round. Does that say something like Creatic or Crentic? I'm going to have to go to double magnifying glass, I think. Well, that would appear to be Creatic CT2105GS, is that? Certainly Creatic CT2105G. Ooh, let's look that one up. Well, this is a single-cell lithium-ion or polymer battery protection IC complex, CT2105, a SOT23-6. Yes, that was a 6-pin SOT23, wasn't it? What's this? A detailed description. Oh, yes. Oh, that is very detailed. Oh, let's find the salient points of that. So it's a hybrid, high-precision, single-cell lithium-ion battery protection IC. Over voltage protection and charging flow, over discharge protection, voltage and flow, current I presume they mean by flow, thermal and short circuit, over discharge protection, voltage flow, is that current? Thermal and short circuit and over discharge voltage stream protection, thermal short circuit protection, reverse polarity protection, batteries and chargers reverse polarity protection, and other functions. Well, lots of functions. Low impedance MOSFET, the RDS milliohms, 58 milliohms is the on resistance. overcharge detection voltage accuracy is soil, does that say? 50 millivolts. Over discharge voltage detection accuracy, soil, 50 millivolts. That translation is not very good, is it? We've got a maximum 4.0 microamps low current consumption. It would have to be, because you don't want the chip draining the cell down below its safe minimum voltage. All sorts here, including a charger detection function. Well, of course, the other two chips in there must be the charger, I would guess. There's a little PDF symbol here, but when you click on it, it just says not found. So I couldn't get a PDF for this chip. But that's quite a lot of detail on this protection IC. Oh, one other thing, it says application is very simple. Peripheral connection, only one capacitor. Well, I didn't see a capacitor. Let's have another look. Yes, there are some capacitors. I mean, they're like grains of sand, aren't they? There's one per chip, it would seem. One there, and one down the side there. There are 3 of these chips. So they can obviously be paralleled up to provide the current. Now, if this is providing over discharge protection, then presumably all the current that you're drawing out of this cell must pass through these 3 devices. So that 4 amps maximum limit must be something like, I don't know, 1.25 amps or 1.3 amps per each of these chips. Wow. So vehicles IR, I think, if I remember rightly. Now, what did I say about current? 1.3 amps times 58 milliohms, that's 0.058 ohms. That would be the volt drop across the MOSFET in the chip. Well, it's tiny, isn't it? I mean, it's less than 0.1 of a volt. Yeah, that seems about right. Now, starting to think my comment about the TP4056 was a bit stupid, but actually I've just typed in a search for 57B3 SOT23-6, and we're getting mention of the TP4057 in a SOT23-6 package. So is that what those other 2 chips are? Well, it looks like you can buy the TP4057 SOT23-6 chip on a little breakout board. That's quite interesting. Maybe I should get one of those. What's this? Differences between TP4056 and TP4057. That looks like worth a read. Aha, the operative features of the TP4056 and 4057 are the same, except TP4056 is in a SOP8 or MSOP8 package. That's like an 8-pin small outline. With a 1 amp maximum charging current. The TP4057, oh, they put 4507, I'm pretty sure they mean 4057, is in a SOT23-6 package and a 500 milliamp maximum charging current. That makes perfect sense that they've got 2 of these things in parallel. Well, now that's interesting. I found a linear technology datasheet for the LTC 4057-4.2. 4.2, of course, is the preset 4.2 charge voltage with plus or minus 1% accuracy. Programmable charge current up to 800 milliamps. Charges a single cell lithium ion battery directly from a USB port. And the application circuit is uber simple. It's simply the chip, the resistor which programs the charge current. It seems that a 1.65K gives you 600 milliamps. And that's pretty much it. They've actually got a capacitor across the input. I'm not sure that's been implemented on this little board. Let's have another look. Well, the resistor here appears to be a 242. I think, yes, it's a 242 sitting next to the TP4057. I can see the significance of the 57 on there now. Incidentally, a couple of LEDs sitting on there either side of the USB socket, red and green presumably for charging. So 242, let's look at the data sheet. Now what's that? 2400, 2.4K. Well, here's the formula. IBAT equals VProg. I'm not sure what VProg is. Over RProg, so that's the resistance. That's 2.4K times 1,000. But I don't know what VProg is. Maybe this is easier. I found an application for 800 milliamps with a 1.25K resistor, 500 milliamps with a 2K resistor. So with a 2.4K resistor, it's going to be a bit less than 500. Now I was measuring 750. That's with 2 of these chips in parallel. What's half of 750? about 375 milliamps, something like that. So that's what's inside a Lumintop 18650 cell with built-in charger, a couple of TP4057s, and also built-in cell protection. These three chips, can't remember what they were called now, but they appear to all be in parallel. And this looks like a perfectly serviceable 18650 cell. Just scrape these bits of metalwork off. Oh, I wonder what that barcode says. And so by the magic of television, here it is completely reassembled. Oh, out you go. Yes, it's the Lumintop rechargeable 18650 with protection circuit and built-in charger. Cheerio.